Good afternoon, ladies and gentlemen. Welcome to our session co-hosted by Industrial Internet Consortium and PTC Japan. Now, ladies and gentlemen, AI, 5G, IoT, are they buzzwords or are they going to change our life? Let's find something new, something important. Now I will ask Dr. Richard Soley, Chairman and CEO, Industrial Internet Consortium, to start. Now, Richard, the floor is yours.
Thank you, Yamakawa-san. Well, we're delighted to be here. We have an exceptional panel for the most complicated pile of gobbledygook acronyms you've ever heard. I think AI, IoT, 5G, AR, VR, everything's in there. But that's essentially what the entire show is about. We're not just talking about pipes anymore. We're not just talking about communications. Anyway, we have a sterling panel. I've asked each of the panelists to speak for about 5 minutes and give us a story that relates to the subject. And then we're going to have a very short time for discussion. From left to right, we have Yoshiaki Takeuchi. He's the Director General for Cybersecurity at the Ministry of Information Affairs and Communications of Japan. My good friend Jun Murai, Professor and Faculty of Environment and Information Studies at Keio University. And all the way at the right, we have Robert Pepper, Head of Global Connectivity Policy and Planning for Facebook. And with that, we'll go straight to Takeuchi-san to talk about, give us a story. Tell us why we should care about this pile of acronyms.
Thank you, Chair. I am Yoshiaki Takeuchi. I have been working for the ICT policy for almost 34 years consistently. And 3 years ago, I was the Deputy Director General in charge of the IT strategy in the METI, Ministry of Economy, Trade and Industries. And last year, I was in charge of the radio spectrum allocations. And in that position, I tried to allocate the IoT and the 5G spectrums. And now, I am the Director General for Cybersecurity in the Ministry of Internal Affairs and Communications. And today, I'd like to talk about the effect and the issues to introduce the IoT and 5G in the real society. So please look at the slide on the back side.
It's here.
On the top. Ah, yeah, sorry. Yes, sorry. So now, recently, the data is quite important. Data is the engine of the economic growth. The IoT devices gather the data in the real space and transmitted in the network. And it will be a big data and analyzed by the artificial intelligence. And in addition to that, this year, the 5G service will be started in several countries. And the 5G has 3 major features. First, very high data rate transmissions. Second, ultra-low latency. And third, the quite large number of the simultaneous connections. By utilizing these features, indeed new services will be realized, such as the automatic driving and the remote the medical services and remote construction, and smart school, smart cities, and so on. And as a result, we could get the paradigm shift in the mobile businesses. The slides show this the effect that conventionally, the mobile operator enjoys a high level of the ARPU, average revenue per users, because the number of the terminal is indeed limited, handset and tablet and the conventional handset only. But in the era of the 5G and IoT, the operator could enjoy the large volume of the new market from the automobile, industrial machinery, and so on. So in this scenario, the paradigm shift will be made. And if the scenario will make a reality, we could expect a large volume of the socio-economic effect in the various fields, such as the reduce of the medical expense and the reduce of the road congested time and reduce of the food loss and also the travel time to work. So the MIC has been conducting the demonstration experiment by collaboration of the mobile operators, the user enterprises, local governments, and the academia. And as a result of the demonstration, we have the confidence that the scenario has a reality. But please draw your attention that if the people living in the area where the 5G service is not provided, they couldn't get the effect, couldn't get the merit. So it is quite important to consider the area deployment as a policymaker. So we expect that the new society will be made, so-called Society 5.0. If we go back to the past, the first generation is a hunting and gathering society, and then agriculture, industry, and information. Now we are in the fourth stage, information society. And by utilizing the 5G, IoT, and the artificial intelligence effectively, we could make the new society, so-called Society 5.0. And in order to make this society a reality, several considerations is necessary. First, free flow of data and information. Second, appropriate protection of the personal data. Third, the trust of the data. In other words, the quality of the data. And third, ensure the cybersecurity. Ladies and gentlemen, if we promote IoT and 5G without the security measures, I suppose that is the worst scenario. So as the Director General of the cybersecurity, I'd like to do my best to ensure the cybersecurity, including the IoT vulnerability measures and the supply chain risk management. Thank you for listening.
Thank you, Takeuchi-san. That brings us to Murai Sensei, who will give us a couple of comments, thoughts about this mess of acronyms.
Okay, thank you very much, and good afternoon, everybody. This is Murai from Keio University, Japan. Therefore, probably my role is to talk about some of the research projects I'm going on, which should be covering all the good things, what Takeuchi-san mentioned, and then also the issues like a lot of issues we have in Japan, and including the elderly, super elderly society, and then the role of ICT and 5G or IoT to solve those issues in a kind of practical manner, hopefully in an inexpensive way. So what we did in this slide is connecting home with the hospital for the healthcare and even the hospital process with the patients at home. So utilizing the internet, of course, but then also putting the high quality of camera, and also all the data is going to be, what we are trying to do is a blockchain type of sharing mechanism for supporting the patient. And then we just, with the support of actually from MIC, then we did the testing thing. So this is one of the things that the medical doctor at home is actually monitoring, utilizing the normal doctor's hospital screens, and which is basically by window. One of the window is kind of the other side, the patient side, which is on the bottom left corner, which is a patient house. And then they are communicating through the TV set. And then there is a camera on top of it. Therefore, both can communicate. But also all the smart house type of a sensor is reporting back to the doctor when they are connected. So they can check, medical doctor can check, like a past week of the, record from running from the sensors and that kind of thing. And we did some kind of interesting testing, including the 8K camera version at the patient side. So the interesting thing about working with a medical doctor is that those are the patient images, but then the medical doctor can just zoom in the camera. So the right-hand side is the 8K, middle is 4K, and the 2K. So because the 8K camera can downgrading into the screen. And then the eye doctor participating on the testing, kind of jumped out. And then he said that this is, the kind of one of the findings he never, ever get from the face-to-face, treatment of the medical patient. So this is, kind of when you have an inexpensive 8K camera at the patient house, then you can zoom it, and then the eye doctor can find the kind of a new way of finding, tracking his patient. And so as the throat and especially the skin doctor were very happy about that kind of equipment. So when the home is connected like that, then it's a very hard even for doing this testing with the actual hospital and the patient, because there's a lot of regulation on the health regulation. Department of Health regulation is totally different from regulation by ICT, right? Of course, a regulation of a spectrum allocation and the other thing. And then the payment is included, by the way, for the design of the entire thing, so that the micropayment with the supporting of the patient at home have to be, recorded and then, in a kind of a secure way. So that's included all the, involved all the ministry type of thing, all the regulation, different regulation, which have been the silos before, but now, because of this type of activity, then all the regulators have to think about to achieve this type of a thing. So this is another one. So the kind of a silo regulations connected each other, and also the practical solution can be solved with devices. But the 8K camera, for example, is going to be used this way. It's going to be different from the 8K for the broadcasting purpose, and then getting a commodity of such a device is going to be, when it's connected, it's a superpower for this solution.
Thank you very much. I never would have guessed this is an academic sort of slide. not even 1 second will take it. I told myself I wasn't going to do this, but I can't resist. Our last speaker, but not worst, Dr. Pepper.
10, 2, and 4.
I'm sorry, I couldn't resist.
There you go.
I was going to call him Sprite, but you wouldn't have figured it out. So.
Thanks, Richard, and thanks for inviting me to be on the panel. So people don't think of Facebook as being an IoT, 5G, maybe a little bit of the AI. So let me put a little context on it. And then what I'm going to do is talk about, in the title of the program, best practices, business and industry best practices. So in terms of IoT, we're actually not doing a lot of the things that you heard, but we do have Oculus, and we have Portal, which is the little device, the little telepresence device, which actually, so you don't have to have your phone to do, FaceTime with your family or my granddaughters. And it's a device. And then Oculus, of course, is the VR headset. And then in terms of 5G, which is actually important to us because one of the things that we do is we have, part of our mission is to connect the 3.5 billion people not yet connected. And we had a lot of sessions this morning, especially in Africa, looking at who's connected, who's not. Right, so we're developing new technologies to use 60 gigahertz spectrum for something called teragraph, which is small cell mesh networks, advanced next generation Wi-Fi at 6 gigahertz, HAP spectrum at 28. Each of these are part of the 5G bands. And so we're actually designing and building products and partnering with service providers and other technology companies in the context of something that we call the Telecommunications Infra Project, which we helped start with 5 companies about 3.5 years ago, that now has over 500 companies, and it's sort of open sourcing technology, but that's using 5G bands. And then finally, artificial intelligence. which we're using to make the platform more secure, to be able to do things like safety check, which I hope none of you have had to use, but maybe some of you have, in situations like hurricanes, tsunamis, earthquakes, so that you can check in with friends and family to say that I'm okay. So we're building all of these types of products that are related to IoT, 5G, and AI, but there are really important questions as we're developing those products and across everything we do in terms of even the basic applications and services within Facebook, Instagram, and WhatsApp, which go to some of the questions that were raised about what about security? What about privacy? And you hear a lot about privacy by design, security by design, but what does that mean? And what we do is privacy and security cannot be bolted on after the fact. It's not something that is an afterthought. It has to start from the very beginning. So we have a process we call XFN, cross-functional process. And it applies to everything that we do. At the very, very beginning of a new product development or modifying existing products or applications, there's a cross-functional team that includes the people from, in addition to the product developers, the engineers, the coders, in addition to them, we have people on our privacy team. We have people on our security team, people on legal and policy, so that from the very beginning, as the products are being designed, they're constantly being reviewed by the people who care about and focus on things like privacy and security. And that's really the only way that you can ensure from the bottom up, designing in the attributes that we want and preventing things that we don't want.
Thanks, Bob. I appreciate it. That brings me to a bunch of questions, but I can see, June, you really want to get in this conversation. In the few minutes we have left, let's try that.
Okay. Yeah, I have a question to Robert.
Are you the moderator? Hold on.
That's okay. Okay. Well, we've known each other long enough that he can ask me all the questions he wants.
I'm sorry. The Dr. Pepper. You mentioned about the kind of a bottom-up manner, industrial, and then also you mentioned about the privacy and other things like a GDPR, and then my question is about when the technology is a bottom-up, and then all the devices connected, and then the device has to be standardized, right? I mean, otherwise it's very difficult to be connected to each other, especially the different segment of the industry. Like what I'm working on, medical industries, medical devices, right? They have their own way of a standard, and then it's not same as other standards of the IoT devices. But
you don't have to explain standards.
Really,
I get it.
This is your day job.
Yeah, and the data has to be hopefully they're standardized, and then so my question is, who's going to be in charge of those kind of hopefully standard way of the handling designing the data, designing the devices, especially when we see the diversity of industries coming into the single space.
Sure. So when you're looking at some devices are going to need to be interoperable and work with each other, and the data is going to be sort of common data. And we think about some of the types of IoT devices in agriculture and transportation, right? If it's the connected car, and you have multiple manufacturers of automobiles, and they're talking to the highway, right? There has to be sort of a standard to do that. Clearly, but when you're looking at something like Oculus, which is a standalone technology, right, for VR that we're developing, it's really, I think, less of an issue. But so it really depends on the type of device, whether the devices are interdependent, whether the data generated by those devices has an interdependency, such as in connected cars and highways, or whether it's standalone. When it comes to things like spectrum, the reason that we're involved in preparation for the World Radio Conference that Malcolm talked about earlier today, I mean, those are global standards and we have to have harmonized bands. So it kind of depends, and it depends, and your question is, who does that? Right? And I would say, Richard, and seriously, I mean, people may not know what your organization does, and I think you should explain it in terms of things like some of the data and data sets, and which is, you don't do spectrum, but when you're talking about the devices and connected devices and platforms and the use of the data and the APIs, I think
so I actually have two major jobs that are worth talking about. One is exactly that sort of standardization we do with the object management group. We have thousands of people working together to develop standards in about 30 vertical markets, in retail systems, manufacturing systems, healthcare systems, and many, many other vertical markets, military communications and so forth. We also developed the first middleware standard called Corba 30 years ago when I was 2 years old. And we also own, for example, most of the major modeling standards, UML, SysML, UPDM, and so forth. But I think one of the more interesting things for this conversation, almost exactly 5 years ago, we started an organization called the Industrial Internet Consortium, or ISC, which builds test beds, and it brings us back to this session. We have about 30 test beds worldwide in manufacturing and agriculture and smart cities and smart buildings and so forth. And the idea is to learn how to implement industrial IoT by doing it, because that's the best way to learn something. And it's amazing to see all these things creeping back in, AI and AR, VR and 5G and so forth. What interests me, and a question I've got to ask, and anybody can take this, is I started my career 40 years ago as an expert system developer.
Prenatally.
Yeah, prenatal, yes. In building expert systems, what we then called artificial intelligence systems and now called cognitive systems. We use neural networks, now called machine learning. But it's amazing to see all this stuff come back. For example, we have a test bed running in a Toshiba building in Kawasaki outside Tokyo, which collects a couple petabytes of data a week. And there's no way any human being is ever going to look at that data. So you've got to have an AI system, a machine learning system that uses that data to learn how the building is used, the heat, the light, the telephones, the people, and so forth. Why are we seeing this all over again? All these acronyms that we've been talking about today, why are they suddenly coming back? Anybody want to take a stab at that?
Well, actually, coming back is very natural. I mean, it's like a, kind of dream comes true type of a thing for the other design of the, kind of original internet. But probably the big change is, probably the question goes to Takeuchi-san that what's the role of the government and then including the industry at the bottom up, then, so I think that part is changing because it's for everyone. And therefore, each of the government has a responsibility on that. What do you think?
I suppose that the role of the government is to make a useful platform for all the industry and the users. And I suppose that the lower layers, like layer 1 to layer 3, probably the technical standard will be made and the type approval may probably be provided. So the user can choose the appropriate devices in company by company and industry by industry.
But to be fair, in the 1980s, we saw the nth generation project, which there was a response in the US called MCC, the Microelectronics and Computer Corporation, and a partial response in Europe called JESI, for example. I don't think any of those succeeded. I would not say any of them really succeeded, except in spending government money. So is it really government participation? Is that the deciding factor?
One thing I'd like to say is that based upon such a lower platform, on that platform, each industry, like automobile and construction and medical services, each industry has important data.
Right.
How to maintain the data or how is the operational requirement. Such kind of the rule and procedure should be decided by the government with the collaboration of the industry.
Because governments are so good at doing things.
Yeah, but I would say that the IIC, the Industrial Internet Consortium, has been really successful precisely because prior to that, we had each industry vertical working on its own, siloed IoT solutions.
Right.
right? One of the brilliances of the IIC was bringing together all of the verticals in the same place.
All the industrial verticals, not
The,
consumer.
no, the industrial verticals focusing on this and actually having them talk to each other and figure out which parts of this actually will have to interoperate. And what you want is something that's interoperable, which is not necessarily doing everything the same way, but they have to be able to talk to each other when you want them to talk to each other, and there will be times that you don't want them to talk to each other, right? For secure SCADA networks, for example.
Security through obscurity.
So, but it's really industry driven, and I think there's a really important role of government as convener to sort of be part of that conversation, but it has to be industry driven, and that's one of the real success stories of the IIC in this IoT, this industrial internet space.
Well, that's true for the industrial, devices and technology side. But the issue is that since it's so successful and then deploying into the society, therefore the people started to use it. So the consumer is impacted on those standards, and then when the consumer is AI and all the software, Facebook or whatever, then when each of the citizens involved, then the government care, right? So that's a kind of tendency that the government would like to.
You're talking about a government that actually is running now, not.
Well, I'm not saying that.
By the way,
I'm not saying that, but the beauty of industrial standards and with the technology side is a little bit different situation now. And
I'll leave you. We're a little bit over time, so I'm going to leave you with a final thought, which is I bought a memory card, 16 kiloword triple height VME card in 1978, cost $16,000, 64 kbytes. I now have 2 gigabytes in my pocket just in case I need it. It cost me a couple of bucks. Maybe that's one of the differences. The cost of memory, the cost of processor power, the ubiquity of processing abilities, and all of these things have really changed the way. I built a voice recognition system that ran on a mainframe in 1982, and it sucked. And I now have one on my phone that I keep in my pocket at all times. That's a pretty big difference.
Yeah, that's for everyone.
But what we have to be, I think all agree that what we have to be doing is collecting these best practices so that we're using these technologies in intelligent ways, and it includes government participation.
Yes,
that's true.
With that, I'm going to say thank you, Takeichi-san, thank you, Murai-sensei, and thank you, Bob Pepper. I just, I couldn't resist.
Thank you.
Thank you very much.